Welcome to our deep dive into the probabilities and statistics of Roulette, the iconic casino game.
First, let's quickly recap the rules. Roulette has 36 numbers plus a 0 in European roulette and an additional double 0 in American roulette. Place your bets on where you think the ball will land by putting chips on the betting area. Bet on a single number, groups of numbers, red or black, odd or even. The wheel spins, the ball lands randomly, and payouts vary based on the likelihood of your bet winning.
Let's calculate the basic probabilities of Roulette. The basic bet is odd, even, or red-black that pays 1 to 1. The probability to win this bet is 18 divided by 37, which is 48.6%. But the chances of winning a bet are less important. Imagine you play 37 rounds with a $1 bet each. On average, you win $18 and lose $19. Minus 1 divided by 37 means that on average you lose 2.7% of your bet each round. This is the expected return. In American roulette, the math is minus 2 divided by 38, so here you lose each round on average a whopping 5.3%. So steer clear of American roulette. The payouts for all bet types in roulette always give the same expected return. Try calculating it on your own.
First, we wanted to test these basic probabilities by simulating 200,000 games of European roulette. Each game consisted of 100 rounds, starting with $1,000 and betting $1 on 1-to-1 bets. The graph displayed shows the money reached after 100 rounds on the x-axis and the percentage of games reaching that amount on the y-axis. We got a beautiful, normally distributed graph with an average of $997.3, exactly matching the analytical calculation of $1,000 minus the expected loss of 2.7% per round over 100 rounds. The standard deviation was $10. The maximum money reached in the simulation was $1,044.
Next, we experimented with different bet types and sizes. We fixed the number of rounds by the bet size, so the expected return will be the same in all cases, minus $2.7. Take a look at the two tables in front of you. One shows the maximum money reached in each case, and the other displays the standard deviation of the returns. It's fascinating to see how the data aligns. Higher risk consistently results in greater volatility in returns. We took our analysis even further. The table in front of you shows the results of fixing the bet size and simulating different bet types over varying numbers of rounds, calculating the standard deviation for each setting. The table reflects a bet size of $1. If your bet size is $10, simply multiply all the numbers by 10. You can see that as you play more rounds, the expected return decreases linearly, while the standard deviation rises, but not linearly. We've also visualized this data in a graph for easier interpretation. With this knowledge, you can plan your strategy before heading into an evening of play. Decide how many rounds you'll play, what bet types and sizes you'll use, and use the graph to understand where you might end up by the end of the night. Keep in mind that 68% of the time, your results will fall within plus minus 1 standard deviation, and 95% of the time, within plus minus 2 standard deviations. A word of caution, the 35 to 1 and 11 to 1 bet types don't distribute normally in small amount of rounds, so the standard deviations are an approximation in those cases.
Thank you for exploring the statistics of roulette with us, but we're just getting started. The real simulations are about to begin. In Part 2, we'll dive into different kinds of simulations that involve risking all your money, not just counting rounds. We'll analyze different bet types, sizes, and intriguing strategies. Trust me, there's a lot to uncover. Hit that subscribe button and head straight into Part 2.